Now we're going to start talking about functions. Functions are the backbone of all of calculus, algebra, and a lot of different areas of mathematics. So it's very important to understand what a function is and the properties of functions. So we're going to start with the definition of a simpler object called a relation. And a relation is a set of ordered pairs. So there's no criteria for what these ordered pairs have to be, just any set of ordered pairs. So if you remember, an ordered pair is an x value and a y value, or any input and output. So this is telling us how x is related to y. Okay, so this could be just a list of ordered pairs, like 1, 2, 3, 4, -7, -8, something like that. Or it could be defined by an equation if there's an infinite number of ordered pairs. So this could be something like y equals x plus 1. So to find the y value, you look at all the possible x values and you add 1 to them. So these would both fit the definition of a relation. The first one has 3 ordered pairs, and so it is a set of ordered pairs. The second one has an infinite number of ordered pairs, so it's still a set of ordered pairs. Now, a function is simply going to be a special type of relation. So let's first look at a few properties of relations that will carry over to functions. So first of all, the first values here, right, in our case, what we're calling the x values, but any inputs, whatever variable you're using, this is known as the domain. So all of the possible inputs would be the domain. And the second values, the output values, are what we would call the range. Okay. So every value in the domain is known as an input. Every value in the range is known as an output. So let's write down domain is the inputs, and the range is the outputs. Now another name for the inputs is the independent variable, and the outputs then would be known as the dependent variables. So this is because the y values, as you can see in the way we define the equation, for example, with the y equals x plus 1, the y values are dependent on the x values, and then the x values are independent. These are the values that go into the relation, that are the inputs, and then the y values are the outputs. So the y's are dependent on the x's, and the x's are thought to be independent. So we typically will only ever have one dependent variable. You could have many independent variables, but in most of the cases we're looking at, we'll just have the one independent variable. So now to move on to the definition of a function, I think it's most helpful to kind of visualize how this works first. Okay. So let's look at this as the domain, and this is the range. And we'll look at the values that we just defined a second ago. Hopefully I remember these correctly. Right, I believe it was 1, 2, 3, 4, and -7, -8. So the domain, the inputs, the x values, these were 1, 3, and -7, and then the range is 2, 4, and -8. So what the relation is saying is that 1 is mapped to 2, 3 is mapped to 4, and -7 is mapped to -8. So every value in the domain is mapped only to one value in the range. And this condition is what makes this would make this also a function. So this relation is actually also a function. So let's write down the formal definition here for a function, and then we'll look at some other examples. So a function is a relation that assigns a single value in the range to each value in the domain. So every value in the range, a single value in the range is assigned to every value in the domain. So in other words, there's only one arrow coming out of these numbers in the domain. So a non-example, something that's not a function, this would be something where one of the x values is mapped to two different y values. Okay, so maybe something like this. So we can see in this case, 1 is mapped to 2, 3, and 4. If we were to draw this, so our domain is just the 1 here. The range is 2, 3, and 4. And we can see that 1 is mapped to 2, 3, and 4. So we have multiple arrows coming out of the 1. This prevents it from being a function. So the reason we don't want this is because we want to know that when we input something into the function, we're going to get one single output. We don't want to get two outputs. We want it to be predictable. We want to know what's going to come out, or that at least one thing is going to come out, and only one thing is going to come out. Now, the other side of this is okay, meaning numbers repeating in the range is perfectly fine. Okay, and by the way, this top one is still a relation. It's just not going to be a function. So every function is a relation, but not vice versa. Not every relation is a function. So another thing that would be a function, something like this maybe. We can just look at the two values here. So this is fine when we have two numbers in the domain mapped to a single number in the range. This is perfectly fine. We'll have another definition later called one-to-one, and this function here would not be one-to-one because of this. So there is a term for this kind of idea, not this idea of not repeating numbers in the range. But for our purposes right now, we are fine with this. This is a function. Now, when we just have a set of ordered pairs, a finite set of ordered pairs, like we have here, and in this original example, it's easy enough to tell if something's a function because we can just look for repeated inputs. When we have it defined as a equation, it can be a little more challenging to determine if something is a function. We have to look for cases where we would not be able to assign a unique y value to an x value. When we look at the graphs of these equations, one way that's easy to tell is by using what's called the vertical line test. So if we translate the equation to a graph, so let's just say that we have a straight line. Maybe it looks like this. So the vertical line test says that, and I'll just write down vertical line test here. This says that if you can draw a vertical line, if you draw a vertical line anywhere on the graph, it should only pass through one point. And this is because if it passed through 2 points, this means that there's a repeated value in there. There's two outputs for that one input, right? So if there was a value here and here, for example, and let's say this is like x equals 4 or something like that, and this is 1 and this is 2, then this means that the point 4, 1 and 4, 2 are both in the set of ordered pairs, so this excludes it from being a function. So if we draw a vertical line and we hit more than 1 point, then we know that it's not a function. So here we can draw a vertical line anywhere we want, and it's only going to pass through 1 point. So this is how we know it is a function. Let's take a look at a special type of equation, which is that of a circle. Okay. So a circle, we won't get into the specifics of circles and what the equations of circles are, but this is a circle with center 0 and radius 1. Center 0, 0, I should say. So it's going to go out to 1 and -1 on both sides of the x and the y-axis. Okay, it's not drawn super well, but so this is a circle with center 0, 0, radius 1. And we can see here that if we look at the point, maybe like 1/2, for example, and we draw a vertical line here, it's going to pass through 2 points. Okay. And this is easy enough to see if we actually plug it into the equation too, if we know what happens when we take the square root of a number. So we can see this algebraically as well. So if we plug in 1/2 for x and see what the corresponding y is, 1/2 squared is 1/4. And then we'll subtract 1/4 from both sides. And we'll get into the nuances of equations later on. So I'm just doing this quickly just to demonstrate here. So we get that this is 3/4. So when we take the square root of both sides, we have to take into account both the positive and the negative square roots. Because, for example, if we took the square root of 4, both 2 satisfies this, right? The square root is asking what number times itself gives us the number inside the square root. So 2 times 2 gives us 4, and then -2 times -2 also gives us 4. So if we're solving in the context of an equation, we typically only look at the positive one, but if we're doing this in the context of an equation where we need to consider every value, then we have to consider the positive and the negative part. So here, the y is equal to the positive square root of 3/4 and the negative square root of 3/4. So 2 different values. So this one x value at 1/2 gives us 2 different y values. So this means that this is not a function. So just to summarize here, if it's a set of ordered pairs, we can just look for a repeated value in the domain. So an x value, an input, being mapped to 2 different y values, that would mean it's not a function. And if we have an equation, we could graph the equation and then look to see if it satisfies the vertical line test. And you could do it algebraically as well by looking for things such as the y being squared, which would give you 2 different values for that one x value.